Bruce, how many people know me here? Okay. I'm with Backyard Skeptics for the 2 people, maybe 3 people who don't know me. And were you at the bar next door? Is this gentleman John at the bar? Let's see. Wayne, is this gentleman at the bar next door?
I went to change my shirt.
I guess not. Okay, sorry. You look like a bar person, sir. I'm just... I'm kidding. So this is number 9, the debates series that we're in. Tonight we're having Dave Dana-Bashian, is that correct? Did I pronounce that good enough? Close enough? Okay. He's a creationist. We decided that while Dave has been offering his services, i.e. bothering me to have a discussion with for the last year on many subjects of which he has questions of. I hope this particular discussion doesn't come to a big argument of ignorance, because from what I've heard of some of the arguments is that therefore God argument, since we don't know the unknown. So I'm interested to see what Dave has for that. We don't have an official atheist debater, and if this has to do with evolution, a theist could debate this that happens to have a lot of knowledge in evolution, so you don't have to be an atheist to argue pro-evolution. There's many, in fact the vast majority of Christians do believe in evolution, Darwinian evolution. I just heard that only 46% of them say they agree with the creation stories, but only 15% of them are grouped in very conservative creationist churches. So there's a divide there of people who believe partly in creation and believe wholly in evolution. So there's a interesting divide there. Just heard that last week on the news, or on the programs that I watch. So there is no official atheist debater. What we're going to be having is a discussion from everybody, both sides, with Dave. Dave is probably going to be putting the creationist argument, so I assume that we're going to have a lot of evolutionary questions. But anybody's welcome to chime in. The thing is that only one person talks at a time. This is a civil discussion debate. No yapping in the corners, yelling out your opinion. If you want to talk, just go ahead and go up there to the microphone. It will be recorded. We're streaming live. Hello, streaming audience. And I'm going to let Dave take it from here. Afterward, we're going over to the Post to have a beer. They do have some great cider beer over there that I have recently acquired taste for. Dave, you're not a drinker, are you? Do you drink beer, wine, anything?
I can be forced to.
Ah, forced to. Okay, well, I'm buying the first one for Dave. Okay, so let's get the Christians drunk and really see what they have on the mind. Oh, I'm teasing you again. Okay, well, this is a little open for discussion. I'm not mocking them. It's just I have the microphone, so there. So welcome, and we're going to start with Dave's presentation. The format is that he will have a somewhat longer time on the first one to get a lot of his ideas out, but of the 16 ideas that he wanted to present, I kind of cornered him into 7 because 16 is just too long and too many things that are fairly over the head of most laymen. And I've read like 18 evolution books, and I couldn't understand some of the things he was starting to question. So I'm interested to find out the 7 that we kind of settled on. So let's go ahead and take it over, Dave. And I'm going to hear you. Go ahead and put the mic as close as you can, and I'll adjust it over here. Okay.
Can you hear me? Yeah. On the mic?
Yeah.
Okay.
It's the one we always go to when we can't make things work.
There. Okay. Thank you very much, Bruce, and welcome to one and all. And I think, as a preface, one of the things that got me most interested in this group when I first heard about it in November of last year was that each side defended its position vigorously, and yet there is a mutual respect between the two sides. And that's what took me as being most unusual and most gratifying to see. That's very seldom seen anywhere. And so I'd like to carry forth that spirit of camaraderie if we could, and let's see what happens when we examine some of the facts. So without further ado, the talk I have is based upon, as Bruce was indicating, my 16 nearly impossible issues for evolutionists to answer, which I presented 5 times now since July 9 last year. And it's been retitled for the purposes of this talk as Do the Laws of Science Comport with Creation? There's my email address if you care to use it later. So it really boils down to saying I'm going to assume the laws of science and show that they comport with creation, in a manner of speaking. There are 4 philosophical schools of thought, and of those, the one that's going to be in focus here is empiricism. In fact, the Backyard Skeptics even have a statement, we need empirical evidence of any claim to accept it as true. I agree with that statement. Not to be an evidentialist, but I agree with the statement. There are, however, a number of non-empirical categories, such as examples of the historical, the spiritual, and the unsensed. And so because they fall into the, because creation actually falls into one of those or more of those categories, I'm going to use an indirect approach. Why? Because it's easier. It's easier to produce a few counterexamples than to try to present the entire panoply of ideas over a wide range of subjects. It's also quicker because I have fewer things to do, and it's more economical as well. Especially since we don't know 1/millionth of 1% about anything. So, which one of these two comports? I'm going to say, I'm going to compare evolution, which for the purposes of this talk is that things are getting better and better and better unabatedly, versus creation where they're getting at the current state worse and worse and worse unabatedly, each in each case without any outside help. I'm going to use an indirect approach and say that evolution doesn't comport, and therefore, since there are only 2 choices, that's the entire set of choices that creation does. What I'm going to do is present them as follows. I'm going to say, how can the universe avoid heat death by first introducing it by saying, why does anything exist at all? Did the universe always exist, and did the universe cause itself to exist? Next, I'm going to say, what is the origin, transportation, and distribution of carbon? By first showing how do any stars exist, how do any elements heavier than iron exist, and what turned non-life into life. Then I'll have 5 topics at the end. How do peptide bonds exist? How do proteins have only L amino acids? How does metamorphosis occur? How do major morphological changes occur? And what creates information from gibberish? With that, are there any introductory questions that somebody would like to ask at this point? Any at all? Yes?
Where do you get your definitions from?
You mean about evolution and creation?
Just repeat the question there, Dave. Where did we get the definitions from?
The question is, where do I get the definitions of evolution and creation? Actually, I'm using a universal notion of evolution rather than just the biological, because evolution can comprise, and probably should, any number of other things like stellar or chemical and so forth. And so the best summary statement for the purposes of this talk that will not be over people's heads is, are things getting better and better and better unabatedly, or are they getting worse and worse and worse unabatedly? This will cover everything at once.
The reason I ask is because I have, sorry.
Thank you.
I take issue with those definitions. That's not how I define evolution.
Okay. The point was that she disagreed with the definitions. We'll accept it from that, but from the standpoint of this talk, that's what I'm going to use. Yes? We have another question, introductory?
Step up, please, so we can hear you.
Yeah, evolution isn't about things getting better and better and better. The environment changes. As the environment changes, organisms have to adapt to the changing environment. So what was good for one environment is no longer good for the new environment. So what might have been even optimal for the previous environment is no longer optimal. So that's why creatures evolve, to adapt to the new situation. It's not necessarily better than what was there before. It's just more adapted to what's here now.
Okay, comment accepted. Any others? All right. I'm going to be proceeding again on the universal level. And first I'd like to mention I have some textbooks. By the way, they're available for anybody to look at later in case they care to see what the actual text says, rather than just what I said it says. These first 2 are from my physical chemistry courses. One of them, the one in blue is from the undergraduate, and the blue is from the graduate. So I'd like to first consider the question, why does anything exist at all? Well, of course, without anything existing, we are not here. There's no meaning, there's nothing. And it's been said also that from nothing, nothing comes. It's not just a matter of why does anything exist at all, but why this particular amount of material. It's been said that there are 10 to the 80th atoms in the universe? Why not 10 to the 79th, or why not 10 to the 81st? And also, why this particular distribution? It's not evenly distributed across the universe or even across the solar system. So why is anything even distributed the way it is? And after having read a number of things over a number of years, it's my conclusion that this topic isn't really even being discussed. In fact, people tend to avoid it because it doesn't seem to result in anything. At least the evolutionist side does this. I'd like to mention that any discussion of existence probably begins with Roget's thesaurus. Why? Well, Roget's thesaurus, first of all, is not just a selection of synonyms and antonyms or structure therein, which was very valuable for the study of the language, but category number one in that, oddly enough, is existence. It stands to reason that if category number one is existence, that the latter categories might have something to do with the possible causes of existence. I bring out Roget's thesaurus because next to the dictionary, it's probably about as neutral a source of reference material as you can possibly get. Any questions at that point? Okay, I'll go to the next
Well,
one.
I'm going to check. Okay, you don't have to get me, I'm the ghost off the camera here, streaming audience. When you said that the universe is unequally distributed, thank you. I don't see how it should be equal or unequal. It is what it is. I think that gravity has something to do with it. I think that dark energy has something to do with it, simply because you say, why is it being distributed unequally? Why not? I mean, you're making it seem like it's one side or the other. Why can't it just be, this is how nature was formed, this is how the universe was formed by natural causes?
All right, when I get to the point of how do any stars exist, I think that might partially answer the question. We're a little bit too far in advance for that, but we'll keep it in mind. The second thing is, did the universe always exist? And I'm going to claim the answer is no, because if it did, we wouldn't be here. Everything would have already dissipated an infinite time ago, according to the second law of thermodynamics. Then, did the universe cause itself to exist? I'm going to say also no. By the way, some people have answered that previous question with yes, and then come along here and answer this question yes also, even though they contradict each other. Did the universe cause itself to exist? I'm going to say no to that one, because if it caused itself to exist, then it would have had to have existed. Catch this, it would have had to have existed before it existed to cause itself to exist. That's a contradiction in logic. And I can string those questions together and form a cosmological argument, in fact. That is, I can start off with, does the universe exist? An application of the first law of thermodynamics, which says that effectively the mass energy of the universe is constant, or as they like to say, you can't win, the best you can do is break even. And so it would be a violation of that otherwise. And then did the universe, so we're going to say that it does exist and that we know it exists. So then back to this question, did the universe always exist? Well, no, because that would be a contradiction of the second law of thermodynamics, which is that the universe is constantly increasing in entropy. That is, it's getting more and more and more disordered unabatedly, which is one of the initial points I made. Somebody has said that the second law is such that you can only break even at absolute zero. And there's a third law, too, that says you can't reach absolute zero, which speaks for itself. There's also a zeroth law that says you must play the game. And so what thermodynamics would tell us is the conclusion is you must lose. That's what we would end up with if nothing were to intervene. So did the universe cause itself to exist? We already went through that. Okay, so continuing the chain then, it didn't cause itself to exist, and so therefore I ruled out all possible material causes of the universe because everything else is a subset thereof. So therefore I have only two possibilities left. Either the universe does have a cause, or it doesn't have a cause. If it doesn't have a cause, then we're trying to ascribe an effect to a cause that doesn't exist. That's not scientific anymore. That belongs in the camp of existentialism, which we saw earlier as one of the possible choices. If it does exist, because we've already ruled out that it can't be material, that leaves only immaterial. Now, choose from the following possible set of immaterial causes: fairies, leprechauns, gnomes, my favorite, flying spaghetti monster, God. You add to the list. Oh, by the way, I take note here that only God even has any testimony. So when somebody tells me that the universe, somebody tells me that my theory is no better than that of a flying spaghetti monster, I will turn to that individual, hopefully kindly, and say, I don't believe in a flying spaghetti monster, you do. And I never get an argument at that point. The following question then is, how can the universe avoid heat death? That would be the dissipation of all heat. Well, according to Le Chatillier's principle, there's no way out of that. That is, the heat will...
Is this your second question of the 7?
This is the first question, actually.
First question? Okay, it says, oh, it is? Okay, I'm sorry, go ahead.
Yes. And as I was leading up to it with those other points, because it was necessary to build the foundation before discussing that. So according to Le Chatillier's principle, which, well, let me explain Le Chatillier's principle. It's found in any standard freshman chemistry textbook, wasn't ours. It says that if you disturb something from equilibrium, like we're in equilibrium right now, but if something came along and shocked the room, we would not be in equilibrium anymore. Le Chatillier's principle says that everything goes back to an equilibrium, and it doesn't stop until it reaches that equilibrium. Well, in the case of a dynamic universe, the constant increase in entropy will continue to cause the universe to head towards the equilibrium, and the equilibrium is essentially, as they might say in the mob, room temperature. Room temperature of the universe is like 2.7 degrees Kelvin. So that will be the unavoidable consequence if it were speaking only of material causes and effects. Since that's the end of the first question, I'll take some more if there are any from the audience. Any questions at the point? Yes.
Warren, can you step up?
Oh, sure.
You want to be on the recorded.
I just was wondering if if the conclusions that you come to are considering the new theories that are out, that scientists say that we might actually be involved in multiverses, not just one universe.
Mm-hmm. Okay, the gentleman wants to ask about relationships of multiverses. Well, first of all, to answer that, I take a little different view from the moderns as far as that's concerned. The word universe, first of all, means everything to begin with. The second thing is, even if you were to posit another everything, I would ask, where would the observable evidence be for that other everything? And I have yet to hear of that. But I'm an empiricist. If somebody wants to show me another everything or the existence of it, there are the observations, I'll be happy to look at it, yes. You have a question?
Okay. Yeah, you don't have to repeat the question if it's on the microphone.
Okay.
Okay, that's good. As far as I can tell, you had 4 of those things, 4 premises that you're trying to build up to God did it. And I think that you're really kind of weak on some of those premises. First of all, nobody knows how the universe has been created. We don't know if it created from 2 membranes coming together or 2 multiverses coming together, or we don't know. So you're really stringing along your premises very weakly. And about the entropy, you're perfectly right about entropy and 2.7 degrees Kelvin and that, but I don't see that boasting your argument at all. You're just basically taking science and trying to use it to say something that God created it. If no knowledge we have, it must be God. I think that's where you're headed. But I don't feel your premises are very strong on the first 4, because most of them we simply don't know.
Well, I would answer that by saying, first of all, you can be the judge as to whether or not somebody else would like to head in that direction. My basic problem is that I see these issues as having evolutionists claim to have answers for them, but when I stack them up against the laws of science that we do know, I run into contradictions. That's the basic thing I would say with respect to that. And I don't need to know exactly what the beginning is to know what the processes are that operate now to find what I believe to be those contradictions. Any other questions? Yes.
Yeah, on the issue of a universe causing itself to come into existence, although it may be possible that somebody has said that, it's really quite a flawed statement, because a universe that doesn't exist cannot cause itself to exist. I would never make that statement.
Mm-hmm.
But that does not prevent a spontaneous appearance of things appearing out of nothing, because you have like antimatter and matter. They can spontaneously occur without ever having been in existence prior to that. That's been demonstrated scientifically, or at least theoretically. So that's not the same thing to spontaneously appear as it would be to cause itself to appear. It isn't causing itself to appear. It's appearing spontaneously.
Mm-hmm. Okay. I would make two brief comments then. One is, observationally, we have never seen anything cause itself to appear, any more than this or anything else, whether it's primitive or design. We've never seen anything cause itself to appear. And as for the quantum fluctuations to which you were referring, it is not a nothing that is causing a particle and an antiparticle to appear. For if it were, then the particle and the antiparticle, once they come together, would form energy. And if we repeat the process, we would have a violation of the first law of thermodynamics, which would be saying that we could cause unlimited amounts of energy by repeating the process to come from nothing. Rather, what is being touted is that an already existing energy field is the source of the particle and the antiparticle, and they can come back together into that already existing energy field, thus not violating the first law of thermodynamics. That would be my answer to that. Another question, yes?
Is it possible that you could have other, in a sense, universes farther than we can see, farther than X-ray radiation, farther than light, farther than what we know as the current universe? Is it possible that there could be other things further out? That's the question.
Some of that was already mentioned, I believe, but let me restate for the record. If there are any such things, then I would ask the same standard regarding evidence to be applied here, and that is, where are the observations? Where are the tests? Where is the correlation and the cross-correlation to substantiate that? One can make any number of hypotheses he wants to, but unless it has actual observations to back it up, I would contend that it's still a hypothesis and it hasn't risen above that. Yes, another question, please.
Is this really an important question, though? How can the universe avoid heat death? We're talking about the universe. We're talking about it's being filled with trillions of stars that are on billions, if not trillions of years of a schedule. And here we are, mortal man, with our grandchildren who are going to be gone in just a century or so. And does this really have significance when we're talking trillions of years? Certainly our sun is going to be gone in, what, another 5 billion years? That's the projection? Okay. So what do we care about the universe at that point?
All right. Well, you can evaluate whether or not you feel that's relevant to you, I suppose, but the laws of thermodynamics would still dictate that that is the eventual end of the universe if nothing should intercede or intervene. And it's a good thing, in fact, that it doesn't deteriorate faster than it does, or else we would all be in great concern, wouldn't we? There is such a thing as a kinetic concern versus a thermodynamic concern. The kinetic concerns are short-lived and have immediate consequences. In the long term are in the thermodynamic. So what we see is typically a ripple around something that is long-term declining as far as order, or increasing in disorder. So any other questions right now? All right. Then
Are you going to be going to number 2?
Yes, or actually they're preliminaries, as I indicated before.
I'm timing it 10 minutes for each section. That'll give about an hour
Okay.
and 20 minutes.
All right.
And we're starting the second section now.
All right. So the preliminary in this case is, how do any stars exist? If we were to start off with the Big Bang scenario, and there might be others that we might wish to start with, but let's start with that for the moment. What will happen to the particles that would come out of a presumed Big Bang? According to Newton's laws, they will keep moving and moving and moving away from each other and never stop moving. Now, what do we need for stars to exist in the first place? We have to have particles coming together and together and together. We have a hard enough time causing compression as it is here on the Earth. We have to have a specific device, and enclosing only a smaller volume at that, so that we can have our hydrogen or helium or whatever other kind of gas that we could liquefy or solidify for use. If we have this much trouble with a deliberate device trying to compress gases, think how much more difficult it would be for stars to form when you have to have a compression of gases over a much larger volume, and especially considering that the particles are going the other way. So I would contend, from just those considerations alone, that we must also take into account that maybe stars shouldn't exist at all if that's all we knew. There's also a flip side to this too. It's been estimated that we have 10 to the 21st stars. How we come to that number, I don't know. And let's assume that we had a generous 20 billion years to work with. On average, then, we'd have to have 50 billion stars being produced every single year for every one of those 20 billion years. Somehow, I don't remember seeing in the newspaper or on the radio or television anything having to do with our quota of 50 billion stars having been met last year. And if you've seen any such thing, let me know. Now, that's as an average. We might be declining in number of stars being produced, or we might be increasing, but the point is it's still averaging to 50 billion stars. Seems to me that we get excited if we even see one star being produced, let alone 50 billion. And again, I emphasize what I would contend is the improbable nature of any stars coming together at all. I'd also like to say something about a topic that's hardly ever covered, and that is, how are there any elements heavier than iron? In the periodic table, iron appears, if you look down the rows there, it's in the 4th row down from the top, and it's towards the middle of the beige section. It's between magnesium at element 25 and cobalt at element 27. This is a chart that one could find online or in this book. It's called the average binding energy per nucleon curve. And in short sleeve English, what it means is how stable is an element in the first place. Iron is the most stable because it has the greatest binding energy per nucleon. All other elements below it or above it in mass number are less favored to form than iron is favored to form. So if we start off, for example, with hydrogen, how that would come when we don't have a star, I don't know, but let's suppose that we did. We can see from the left side of this chart that fusion would drive the process up to iron. And there it would end, because everything else is less stable as we would continue in greater mass number. In fact, you can see from the chart that to drive things back in the direction of iron would require fission from already existing elements, like, for example, uranium-235, that's element 92 on the periodic table. What is the presumed explanation or proffered suggestion regarding getting the other elements between iron at element 26 and uranium at 92? Supernovae. Well, it remains to be seen whether or not supernovae could in fact produce those, though it has been widely hypothesized. But I have a different problem besides that. It's also the distribution problem. How would you have any elements in economically viable amounts between iron and uranium if in fact a supernova is driving the process of producing them in the first place? That is, everything is getting scattered further and further and further apart rather than coming together. This problem is very much echoed in the carbon problem that I was introducing this topic with. By the way, here's a textbook. That's the same one here I described. Average binding energy per nucleon curve. It's the initials I've given there. Here, for example, is a chart of the world's mineral deposits. It's a little bit hard to see there, but you can see that there are many blank areas. Some of those blank areas are because they've never been discovered for that purpose, perhaps Greenland and northern Siberia. But there are other places like Central Africa, which probably have been. In any event, it shows the non-uniformity of the distribution of a number of metals, as you would see, uranium, silver, iron, gold, and so forth. So what we see in distribution is that not everything is uniformly scattered. In fact, if it were, it would not be economically viable. Instead, it appears in clumps. Many of those precious materials occur just in South Africa or Russia, if we were to look further. Let me also preface this by saying, what turned non-life into life? That is important for this discussion.
That's a pretty big discussion. You want to do a Q&A of the stars before you get into there? I know it's 2C.
If there is a call for that, is there? Yes, whichever, yes.
Hi, I was just looking at where they got the number of stars from, and it was estimated there was 10 to the 12 for 10 of the stars in our galaxy, and then they said that based on that, there's also about 10 to the 12 galaxies out there. So that's kind of indicating the fact that we're not going to be able to see every single star that is created, and because there's only be a limit to what our view is, but we can see and have the effects, you know, studying this space, like that there are galaxies out there, but we wouldn't be privy to this, the stars being emerging in those other galaxies because our tools aren't powerful enough. So I think that kind of plays with the 50 billion a year appearing that it would be in our observable sphere.
All right. Okay, point taken that we wouldn't necessarily be seeing them. I'm just talking about them being produced.
But
You can talk, yes, go ahead.
yeah, it falls into each other. Like they can be produced, but we wouldn't be able to necessarily recognize it every single time because it's so large in space.
You can't observe it, you're saying?
Right, at the exact time of it being created.
However, what I was doing...
Next person who talks, just remain up there if you have a follow-up, because we could get it.
Okay. However, what I was doing was contrasting it against that we would get excited if we even saw one being formed. So you could use whatever upper limit you want instead of the 50 billion that would have to be produced throughout the universe. But the point is that we get excited if we can even see one, and how many ever you have is going to probably be some larger fraction than one.
Yeah, I just think that's an indication of how big the universe is.
Okay, all right, point taken there. Yes? Another question, please?
Good evening. It's been pointed out that the universe is a large place. If the Christian God made the world for humankind, why did he produce all that surplus space? In other words, we seem to be occupying a very small pinpoint in the cosmos. Why was all that redundant space created?
Oh, I suppose we could speculate on that. I'm not sure what that has to do with the rest of the presentation. Would you have another reason than that? In other words, I see it somewhat as off the track here.
Well, I'm merely making the comment that you've stressed the fact that the universe is extremely large, and I'm trying to link that to the Christian creationist viewpoint with which you were introduced.
Actually, I wasn't trying to say anything about this, the size of the universe as much as this number of stars that would have to be in that universe. We could discuss the matter of what the size would have to be. For example, 13.7 billion years if you're going to assume a Big Bang, and I don't even necessarily contend that there's that many years to begin with. Anyway, yes?
Okay, well, if you don't feel that the question fits at this juncture, perhaps you could address it more fully at a later point.
All right, or in private. Yes? Go ahead.
Well, I would just like to comment on that question. I think it's a good question.
Okay.
The universe is, the firmament declares his handiwork. God didn't need to make our eyes quite as complex, I don't imagine, as he did, or our ears as complex, but I think it's a testimony to his creation. His invisible power and attributes are clearly seen by the things that are made so that they're without excuse. And so I think God gave this big universe as a testimony to who he is.
One might also speculate, and that's about all related to, is that we would probably need all the things that have been made just to keep any one of those things in balance. But that would, of course, be purely a hypothesis on my part. Yes?
Last question on this part.
Okay. As far as the star formation in the galaxy, our observable sphere is not that far, and there have been supernova And typically when a supernova explodes, it spawns a whole bunch of new stars to be formed in our galaxy. Within our own galaxy, we can see young stars that have formed. In fact, we've seen dust coalesce around, and all of a sudden, where we just saw a dust cloud, we've seen stars. How does that fits pretty well into the numbers of the galaxy and new star formation.
Yeah.
In fact, in the young universe, it was a lot more stars things have slowed down a little bit now since we're pretty old.
Well,
Well,
that's the way things have been presented, at least. I wasn't really considering the matter of stars breaking up into other ones, but rather the formations of new ones, if there in fact is that is occurring. I say the point is that we are still excited if we see one being formed.
Because they're so far away.
Well, however you like, the point is...
And we do see them, and it is exciting.
Okay. All right, okay. Any other questions at this point?
That was the last question.
All right.
You can go to number 2, and I'm starting the time at 10 minutes again.
Sure, okay. Well, actually, I've still got yet to go into the rest of 2. What turned non-life into life is an important concern here, and I'd like to just mention briefly, suppose I gave you a dead dog. It's been dead long enough, 3-4 days. One small task, Hercules, breathe life into the dog. I've given you everything the dog has, its heart, its lungs, its liver, its spinal column, its spleen, and so forth. Just breathe life into it. What's the matter? Aren't you Hercules? Is this not a small task? Well, maybe the problem is much bigger. In fact, if we can't breathe life into a dead dog, then what makes us think that we could breathe life into materials made into a dead dog? Not only that, but we don't even have the dead dog if all we have to start with is hydrogen. Or maybe just that infinitesimal that came from the Big Bang. Point is, I don't see anybody coming even reasonably close to getting non-life into life. And no, we can't let RNA say it's doing all the work. That's just a hypothesis right now at best. But I'm an empiricist. If somebody wants to come forth with how we could even reasonably get from non-life to life, listen, under certain scenarios. Let me then go on to the last part of this, and that is the focus here, and that is, what is the origin, transportation, and distribution of carbon? This is a hardly covered topic. First of all, we have to ask the question, what is the source of carbon in the first place? But before that, I'd like to some help from the audience, and shout loudly because we have a microphone over there. This picture shows what kinds of examples of carbon do you see or not see in this figure? Anybody, please, name one.
Coal.
Coal is one. What's another one?
Diamond.
Diamond, yes.
Ferns.
Grassy.
Right, vegetation. Anything else?
Air.
Carbon dioxide.
More specifically about air, carbon dioxide. Yes. What else? Anything else?
Humans aren't there.
Nah, just in the picture.
Was that stone or something?
The stone. Well, I don't see the carbon there, but we can argue about that later. Anything else? It's amazing nobody comes up with the next one. Yes?
Life, the green stuff.
Right, they just mentioned that.
Oh, sorry. There might be some limestone in the picture, which would have carbonate in it.
Oh, that's an interesting suggestion. I haven't heard that one. That sounds great. I like to hear those kinds of things too. I know you're very creative, Don. Thank you. Anything else? Okay. How about carbon monoxide? How about methane? There are any number of gases that have carbon in them, which you can't see, which may or may not be in this atmosphere. But my question is, where did the carbon come from in the first place? That's a problem that supposedly was solved in the 1940s, 1950s, and earned a Nobel Prize. What does this suggestion take the form of? Hydrogen atoms from stars form helium. And normally that's the farthest we would get, because among other things, helium is a noble gas. And there are mass numbers 5 and 8 where we cannot incrementally add nucleons to get higher and higher elements. That's part of the reason why that chart I showed earlier about the average binding energy per nucleon curve, you might have seen that there were little ripples very early in that graph. What was the proposed solution? That even though mass number 8 is normally a barrier to any further formation, it was hypothesized that 2 helium atoms, which came from hydrogen atoms, collided to form a transitory species, and before it can disintegrate in 10 to the minus 15 seconds, a third one comes along and forms atomic weight 12 for our carbon. It can only be done at 1 nuclear resonance, only in red giant stars, and can be disseminated only by a supernova. Same process as we mentioned with the elements heavier than iron. Our sun does not qualify as a red giant star that can supernova. It never has, and even when it gets to the stage where it would, it's still not big enough to supernova. Where is the nearest red giant star now that could? Minimum of 33 light years, maybe as many as 40. Ask yourself if a red giant star from 33 to 40 light years is going to jet all of its supposed carbon in the direction of the Earth, such that you would form miles deep, thousands of miles long, solid coal beds, as you can see from this graph of world coal deposits. Notice, by the way, that they are also unevenly distributed, in fact, much more so. Yeah, well, that would give me some pause, too. But the evolutionists out there posit that maybe there was life already existing on the Earth, and that it was submerged in peat bogs and so forth, unless we would have this. Well, the first question I would have is, why the unevenness of the coal deposits? Notice there's almost nothing in South America, for example. And then the second thing is, you would have to be responsible for creating life in the first place to get to that stage. And that was the reason I presented the how do we turn non-life into life? This is a book that describes those mass gaps. Okay, do we have a question here on that point?
A question regarding the coal formations.
Mm-hmm.
There was a very embarrassing episode for some Harvard graduates who were asked, how does a tree get its mass?
Mm-hmm.
And they were saying that water was pulled up along with minerals. And for those of us that had basic biology, we can remember that there's xylem that takes the water up, but then there's phloem, which is part of the vasculature, which takes the work of the leaves and puts it back into the growth areas of the tree. So these trees then are using their food, and the food is sunlight and carbon dioxide, to make sugars. You can get maple syrup from some trees, and you get carbon sugars. So the air that comes out of your nostril right now, the CO2, a month from now, can be in a tree in China. So as far as being irregularly formed, if this Earth had a soup of vegetation that was unevenly distributed, and this product of photosynthesis then was just dropping down, more forming, dropping down, becoming bituminous coal eventually, and then the great anthracite that we appreciate as a fuel. Obviously it's going to be in various areas, and obviously that carbon dioxide can get from any point in the Earth to that photosynthetic operation. And as far as where did the carbon come from, it's my understanding that all white dwarf stars have given off a lot of carbon. Do you agree with that?
If they were red giant stars to begin with and supernova, that's the only way of getting it. That's the point. That was what the Nobel Prize was all about, in fact.
Only the supernovas.
That's the only way of distributing that carbon that's been formed in the red giant stars, and that's the only ones that can be formed in. Okay.
To me, it's no different than water in our atmosphere coalescing. There's adhesion taking place, there's gravity taking place, and those little minute portions of H2O then combine, they become a puddle, they become a river, they become a giant ocean. if that's in the atmosphere, is this not possible for these to cling together? And then, because of gravity?
Well, there are a lot of things that might be possible, but I always ask that same question, where's the observational evidence that that's the way things actually occur? And again, I would point to the unevenness. For example, notice again South America having almost no coal deposits at all, but there is plenty of vegetation, especially in the Amazon region of Brazil. Now, why not any coal there?
Well, was it there 2
Well, we could speculate all we
4
want
million
about
years
that.
ago during the Carboniferous period?
Well, we can speculate all we want to, but I'm looking at the evidence that we see now, and if the present is the key to the past, then we should expect to have seen such things like that also then in their times. I'm just trying to point out there is a vast discrepancy in the coal deposits that exist, and furthermore, you have that additional problem of how non-life became life. You have to also solve that problem as well, or else you won't get this to occur, presumably.
I don't have the answer as to how life began.
Very well.
I'm not sure.
Very well.
Either. But because there is uneven distribution of coal, are you indicating that God is responsible?
I'm just posing the questions. I'm not trying to make claims. I'm just trying to pose the questions.
Fair enough.
And that's mostly, by the way, what I am doing throughout this. I'm not trying. I will not fall into the God of the Gaps routine, for example.
Okay.
Fair enough?
Fair enough.
Terrific. I like to hear that spirited question there. Yes?
Hi. Yeah, you covered a lot of things I was going to look at, but before coming here today, I was researching, how coal is formed, and according to the U.S. Department of Energy, it's not just hypothesized that some people speculate it could have been under bogs. That's how it is regularly seen to exist by swamps and everything. So it has to have the right criterion for having that kind of not only vegetation, but has to be submerged underwater for coal specifically to occur. And so when you look at those regions, those are just those regions that supported those requirements. I mean, there are certain regions of the earth that we look for fossils that aren't found everywhere else. Like, people lived everywhere, but the places where we see fossils have to be extremely arid, and extremely dry for fossils to survive, so age. So any interruption within the certain requirements, so South America, it being closer to the equator, being more hot, more humid, it could possibly break down the process of coal being able to develop in the way that it needed to develop, like its crystalline structures, being able to do that. So I think that's just an indication of that's what survived those situations from swamps.
Well,
occurring.
Right. First, I would mention again of my penchant for observational testing and so forth. Now, you might be able to produce things like this in the short term. On the other hand, we see that there are large coal deposits, and you might notice where they are located of all places. First of all, they're unevenly distributed, but they're not unevenly distributed in similar areas. Notice, for example, in North America, that the coal deposits are mostly in the Appalachians reaching down into Mexico, but they are also found in the Great Plains where there aren't any mountains at all. And they can also be found in northern Montana and up into Canada. These are completely dissimilar regions.
There are dissimilar regions that could produce, so in the southern United States where you have the Appalachian region, it could be flooding, from the lower elevation. Up in Montana, it could be a glacier, coming away and filling up with water. So however you get water covering a large area of vegetation, so it doesn't have to have the exact same region, because that simple occurrence of water over land.
Right. I'm also concerned about the absence of it elsewhere in similar regions, and that's what I was driving at.
Right, understood. And okay.
We have only limited time, I think. Okay? Yes, another question, please?
Yeah, you're saying observational evidence, that's basically what you go by. Well, we don't, with Pluto, we haven't seen it actually travel around. We haven't seen it long enough to observe it going around as a species. But I would assume that you think that Pluto orbits the sun, so we think about how something happens based on the evidence that we can see. We haven't, like I said, I haven't seen Pluto go all the way around, just like we haven't seen coal being formed a long time ago, but we can see coal or coal-like things being formed today.
Well,
observing.
Right. You're correct in saying you'd be correct in saying we don't have a complete body of evidence to show one orbit of Pluto. Right? Yes. Fortunately, however, we have observations elsewhere of of heavenly bodies, and those heavenly bodies have otherwise shown themselves to behave according to Kepler's laws, plus or minus. And so on that basis, we have reason to believe that we will see an orbit however, it is true that in the strictest sense of the word, it's a hypothesis, but not quite without hope, because we have other observational evidences that are similar enough to cause our hypothesis in the orbit of Pluto to follow the path that is projected for it.
And same with coal. I mean, same with things being formed. Coal could be formed the same way, and we can see stuff. If you go to like Florida and stuff like that, where you see a lot of the wetlands, like she was saying, you can see vegetation breaking down and becomes the same kind of stuff.
Yeah.
So I mean, that's why if you associate that same thing, you can say, hey, just like Pluto goes around, we see what's happening right now, and we can go, 10,000, 20,000, 100,000 years, a million something, whatever, and we could associate that same thing. That's what I'm saying.
Well, we could. I would say offhand, those two situations are dissimilar. First of all, if you look at Florida, there isn't any evidence of it right now. And the other is, in the case of Pluto, we were talking about a particular trajectory, not going outside that trajectory. In other words, we believe that it will follow that particular one if we follow a 17-degree out of our plane orbit.
You've never seen any breakdown of tissue or breakdown of organisms, not tissue, but organisms that creates like that sticky stuff. And I mean, I'm not a scientist, I can't tell you exactly what that is. But
well, actually,
someone else can.
Well, there's also been some observational evidence from other quarters having to do with the rate of formation of coal. It can be accelerated or decelerated depending upon the ambient conditions. But we should probably let it go right here if we could. Yes, we have two people that want to ask a question now.
I'm sneaking in on you. That's right.
Okay.
A dead dog and parts of a dead dog are totally different than the parts that make up the amino acids and the things. So I think that's a non sequitur for your argument with a dead dog. And you don't have to respond on these. I'll just mention real quick things. You mentioned RNA. You're not going to accept that RNA produces the life. I think that the majority of the scientists do that. And even if you're right, don't you want to roll up your sleeve and find out what makes life, or how abiogenesis works? And about this carbon being made, you're making it seem like it's so odd that it's so all over the place. When if you look back, all of these things have one thing in common: the way the carbon is made. No matter what it seems is now, and even back then, there might be several different ways that these plants became underwater. Don't you want to find out? You're asking these questions, and I'm a little concerned about, you said you didn't want to go through the gods of the gaps, but where is this leading? If it's, to me it's leading, well, let's roll up our sleeves and go find out. Don't you want to find out, or are you just going to say, look at this wonderful thing about the stars, one star being amazing, and there's millions made every day? If it's so natural, what's so amazing about it?
Bruce, with all due respect, could you focus in on one question, please?
I'm sorry. You can focus in on one answer, because I kind of held back on that one. So
I imagine you did, yes.
But you can just move on.
All right. Well, I think as far as exploration, we of all people would be the ones to explore the most. And if anybody wants to provide intermediate answers to anything, I would be more than happy to entertain them. In fact, that is how science proceeds. However, I'm going on the observations, the testable data that we have now, and that is what we have now. And until something comes forth further, then we have nothing to modify. If more data comes in, then we shall be happy to modify according to the dictates of empiricism. And now we have another question back here.
Yeah, it seems like you put a lot of emphasis on observational science.
At least I keep saying so, yes.
What's that?
At least I keep saying so, yes.
Yeah, and testable data.
Yes.
So when are you going to present some in favor of creationism?
I didn't say that it was.
So it's just going to be a series of red herrings?
Well, no, it wouldn't be red herrings. The reason I'm pointing out is I made a dichotomy between the two, and also because time is of the essence. We don't have endless amounts of time. It would take many years to try to prove the case by evidence directly for creation. And not only that, but somebody could say, but you didn't cover that area or this other area too. That's why I led off by saying, I'm going to use an indirect approach.
But can't that same argument be used for evolution?
In what way?
Just exactly the same way you just said it.
Well, if you want to present an indirect argument for evolution, I'll be happy to listen to it, but that's the best I can do right now.
So, in other words, you hold evolution to a higher standard than creationism?
Nope. I hold it to the same standard of empiricism. Yes, Dave?
Well, I might just comment on that. The idea of the fact that you're saying it can't be done, there's only two possible worldviews, either a theistic explanation for things or non-theistic. So if you disprove one, you prove the other. If you show it couldn't happen naturally, then the only logical explanation is that it had to happen supernaturally.
Yeah. All right, comment. And any other questions or comments at this point? Another one? Yes.
I don't know if everybody accepts it, and maybe it's just a feeling of disappointment in me.
Oh, that's too bad.
That God would, a God would make one tiny planet and then ignore the entire rest of the universe to be making other beings and have them enjoy the same kinds of life and things that we're enjoying. And so that would be a large disappointment that he wouldn't be giving a creation that's full of life and therefore purpose.
Mm-hmm. Okay, comments taken in their context. Anything else? All right. Well, then
Would you like to start the next section?
That's the idea. All right. So the next section, from here on out, there are no supporting questions, just the questions themselves. How do peptide bonds exist? Now, I'd like to show by example what I mean by that. Well, first of all, you can see some indication in the figure. The colors are different, so maybe I should interpret the colors in the figure first. If you see that the blue atom, that's a nitrogen atom, because there are only two components connected to it. Everywhere you see a white atom is a hydrogen atom. And the blacks are carbon atoms, and the red is an oxygen atom. Now, what we see in this figure is what's called a condensation of glycine. Let me show also from one of these figures, since it might be harder otherwise. This is a more general figure, if you're allowed to see it here. This green in mine, I'm sorry the colors are not the same. The green in mine right here is the nitrogen atom, and you can see two hydrogen atoms associated with it. That is called an amine group. If you've heard of ammonia, it's the same idea except that we'd have three hydrogens. On the other side is what is called a carboxylic acid. It consists of a carbon doubly bonded to an oxygen, and on the other side, a single bond to an oxygen that is bonded to a hydrogen. COOH, carboxylic acid. The central carbon atom is right here, and it also has a hydrogen atom, and it has a functional group. In this figure, the functional group is another hydrogen atom. It could, and by the way, notice that the red in this figure does not correspond to necessarily to the red in that figure. In this figure, it means something else, I think. But whether it does or it doesn't. In any event, the functional group could be another hydrogen, which would make it glycine, or it could be any of 19 other functional groups. Notice that in the condensation, that is, if we hook two of these together, notice what drops out. What's that? What do you suppose that molecule is at the bottom of that big structure underneath? Do you have any idea now that I've introduced?
Water.
Water is correct. Have you ever heard that belief that that we all came from a warm little pond? Just how is that going to occur when a water molecule must drop out not be absorbed by the amino acids that form the peptide bond. This is a problem. Okay, let's suppose we don't even have a warm little pond. I don't know how you get the two next to each other in that instance, but let's suppose that you don't. In that case, you have only dry land to work with. The dry land will either have an oxidizing atmosphere or a reducing atmosphere. That is something that doesn't have oxygen in it. If it has an oxidizing atmosphere, then the oxygen, the free oxygen, will come and destroy the bonds and maybe destroy the amino acids in the process. On the other hand, if we don't have any oxygen and we have a reducing atmosphere, then we also don't have any ozone, and the UV rays can come in and they will destroy the amino acids and maybe the bonds. The bonds and maybe the amino acids. In other words, amino acids do not form peptide bonds in the open. They can't for those three reasons. Instead, any such condensation will occur only in already existing bodies where the water is carefully wicked away so that it does not interfere with the process. Here's a chart to show the reaction itself. Each one of those two on the top left side is an amino acid. When they combine together, the oxygen from the amine group, one of those two, plus the hydroxyl group, the OH from the right side or the left side, that's what forms the water molecule that drops out to form the peptide bond, as you can see on the right side. Continuing to chain these together, we can form an amino acid chain where R1, R2, R3, and so forth are the functional groups. And that's how you form a protein. But in each case, it's a water molecule that drops out. If you don't have the peptide bonds forming, you have no proteins, you have no enzymes, you have no life. This is absolutely necessary. Do we have any questions at that point? Yes?
Yeah, in the oxygen isn't normally floating free in the atmosphere. In the beginning of the Earth, even when the first life was around, what caused the first great extinction and life was oxygen. After photosynthesis happened, it started creating a bunch of oxygen in the atmosphere, and it caused the first great die-off of the life that was here on Earth. It normally wasn't found free. So it could be argued still that the UV rays would, unless you were underwater.
Mm-hmm. It certainly could. So. And if you're underwater, it will still not cause the formation because it's water. But I would also point out that you have assumed that life begins with, that there's life there to begin with, and I'm talking about something where there isn't even any yet there. Mm-hmm. So we can't even assume that life is there. That would be assuming the given.
Yeah, but assuming that oxygen was here would also be making an assumption because it wasn't.
Well, but there are any number of things where even if you don't have free molecular oxygen, you have enough oxygen that is activated so that it can still come in contact with. For example, you can have free radicals forming in the upper atmosphere from the oxygen, and even if you still don't have free oxygen, you at least have oxygen radicals. It could still cause the oxidation to occur.
At very, very low levels. Most of the oxygen is...
Okay, the point is there can be at least some, yes. Any other questions now? Yes, another question. By the way, I enjoyed this very spirited discussion and the openness and the civility too, yes.
There was a time when humans huddled together in rainstorms and lightning struck, and they were terrified, and they tried to understand it, and they said, well, there must be a God. We're doing something wrong. We have to appease this God. Let's make a religion. And then there was a time somewhat later when Christianity was firmly established in the 1300s, and the bubonic plague swept through Europe. And people prayed at that point. And the conclusion that they came to was that the Jews had been causing this problem. And 100 years later, there was a little ice age. This little ice age baffled the Pope at the time, Pope Innocent VIII, and he said, it's not natural. it's witches. And I'm just wondering what scientists are going to say 50 years from now if they happen to check out our conversation tonight and find that here we are wondering why there could be dehydration of amino acids during the formation of peptides, during covalent bonding, and we don't understand it, so it must be supernatural somehow. Now, you're not really saying that. I think Dave would say that God's in charge, but
well,
I just wonder where we're going and how we're going to look in the future.
Well, that's a subjective opinion, I might say, and it remains to be seen anyway. The point is, I'm still pointing in the direction of empirical evidence, and what we have now is what we have to work with. Somebody may suggest a hypothesis, it may gain traction with further evidence, and let me not be the person that would stop the evidence from going wherever the truth would be. But in the meantime, this is what we have now. Yes?
Hi, yeah. I appreciate your grounding in molecular structures. You outclassed me for sure in that. But I was trying to be more informed on the topic, and what I came across was the fact that proteins are not necessarily all similar to one another, and that there are different proteins made of different peptide bonds. Some will be hydrophilic, some will be hydrophobic, and they would actually adapt to their environment, and some would disintegrate in certain environments while some others may thrive. I believe scientists actually identified some adaptive proteins considered within the environment. So how would you, just saying, I just wanted to make the statement then it seemed like there's different kinds of proteins that existed in different types of areas and environments, and not all had the same abilities or fallacies.
Well, first of all, proteins are formed purely by linear peptide bond extensions this way. They don't even branch. That's the key. It's always linear, and it's always accompanied by water dropping out. It always is. Now, what you may be referring to, for all I know about different peptides, different proteins, is the functional groups that might exist in those. What order they appear in, and where, and how many of them appear. There is a great variety, of course. When you have 20 different ones, it kind of form a language, if you like, of 20 letters. And not only that, but there are other concerns that I have not brought up because they would be confusing, but they have to do with the folding of the protein being optimal and so forth. And even one of these out of place would be enough to perhaps cause injury or death to the organism. But those are other concerns than the basic ones I have right now. And the basic ones I have right now, I'm trying to show that peptide bonds do not form out in the open. There's no way to control the circumstances of wicking away water and causing either oxygenated compounds or free oxygen to destroy the bond, and or UV rays doing the same. That's the main point I'm making here among all the points I could make. All right? Any other questions at this point?
One over here. Sure. Have you asked a geologist
about what?
How coal forms? Have you asked a molecular biologist how peptides bonds form?
I think it would be better asking a chemist, and that's what. And since I have a degree in chemistry, I can already do so. Yes.
What is the general consensus of how peptide bonds form?
This is how they form. It's not just a consensus. This is the empirical data, and there's nothing to contradict it either. This is how they form.
And what's wrong with what they form? You're saying that it wicks away water. You're saying that it doesn't happen out in the open. Is that your argument?
What I'm saying is that peptide bonds don't form out in the open because of these considerations.
And that is what does that mean? No life? I mean, I'm trying to follow you here, but right. you're saying a negative here, but no consequences to it.
No, not at all.
What's the consequences?
Well, again, I asked the question, if you might recall, have you heard the argument or tale or whatever that life formed in a warm little pond? And I asked the question, how is that going to
We don't know that. It could have formed under the ocean, for that matter.
I'm trying to say, if you'll recall the sentence that I made, thank you very much. How is it going to form when water has to when water would have to be absorbed by the amino acids rather than lost by the amino acids, which is the actual reaction? That is my question that I put forth. And I have had no takers because it's pretty obvious that it can't have it wicking away and being absorbed at the same time. Yes. Anybody else? Yes.
I don't know much about molecular chemistry either, so I have to bow to you to that point. But if we are 70-ish% water, and yet these things form all the time, I don't know exactly how that happens. So maybe
it is an obvious question, yes. And I somewhat brushed it aside. In fact, I'll have to plead some ignorance here. But there are mechanisms that would cause it to wick away. Otherwise, we would not have any proteins in bodies either. But those structures don't exist outside the bodies. Yes.
You don't know what they are. You just.
I'll look them up for you if you want, but I was concentrating mostly on the fact that it cannot occur in the open.
So I could look up how peptide bonds form in water as well.
No, what you'd be doing is looking up how they would form in spite of the fact that there is water in a body. In other words, what carries the water away. So but there can't be water in the formation. Well, if you introduce water, it will reverse the reaction towards starting materials.
So you're saying you could look up how it happens in water, but you wouldn't look up how it happens outside of the human body somewhere else? Is what you're saying?
Okay. Peptide bonds do not form in water.
Okay.
It's as simple as that.
So there's certain parts of our body that don't have water.
The point is that he's saying it can only form in water, and so it's.
No, I'm saying it can only form in structures that wick away the water, and we don't know of any automatically available unless they are already existing bodies.
Well, let's roll up our sleeves and find out.
Sure, if in fact it comes to it. Actually, the structures that wick away the water are known. I just don't happen to be able to have the evidence right here. But the fact is there have to be such structures. Yes?
Would you like to hear what those structures are?
That depends on how much time we have.
I vote yes.
Would you like me to do it now? Okay, there's a structure.
You have 1 minute.
Okay, 1 minute to say, oh great. In every single living cell there's a structure called the endoplasmic reticulum, along which are little points called ribosomes. Those ribosomes are little machines that I've described earlier at one of these debates that are actually computer numerical controlled machines that line up the protein, the amino acids, and set them up with the amine group to the...
You need a PowerPoint, Don.
Yeah, I know I do.
30 seconds.
Lines everything up, and then they have a little hammer that goes kerwhack and knocks the water molecule off and hooks them together. It's a tiny little machine, looks like a sewing machine running, and it has a little hammer on it that every time the pair goes through, it knocks the molecule off.
Thank you, Don.
I know it works. Thank you for supplying that valuable information, and maybe that'll answer a few questions. Do that too.
Okay. I think we're ready for our next topic.
All right. Now, why do proteins, or how do they have only left-handed amino acids? Now, that topic may not be familiar to many people, but unless, of course, you've had some organic chemistry, like I've had a number of courses and labs in, here's what we mean. Remember earlier that I held up one of these as a model of an amino acid, and I pointed out the component parts. The amine group, the carboxylic acid, the hydrogen, and the functional group. The spatial geometry of this permits there to be another kind of amino acid, specifically the mirror image. Can you see that that's a mirror image? Look at either the diagram that's projected over here and or this set of models. I'm going to try to keep my fingers as far away from possible as that. Can you see the fact that these are mirror images? I can draw a mirror between them. Can you see that? Yeah. I think that's it. I just regret that I don't have bigger models. Now, however, there's no way to stick one on top of the other so that they all match. It's not possible unless you were to break the bonds, which is somewhat cheating. And the reason you can't is because of the spatial orientation, if you like, the fact that it's in 3D in just this way. There are other kinds of left-handed and right-handed structures besides that. There are an infinitude of them, frankly. But they're important in this case because despite the fact that amino acids can form left-handed or right-handed, under neutral ingredients, a neutral energy source in a neutral environment, in a 50-50 mixture, plus or minus a tiny amount, only left-handed, only one of these amino acids appear in proteins, and that's true of every amino acid in every protein of every species. They're all only left-handed, despite the fact that they form in equal quantities under laboratory conditions where everything's neutral. In fact, if you see that blue book up in the upper left-hand corner, that was where my attention was first drawn to it, even though it's also discussed in the one to the lower side, the organic chemistry. It's discussed on page 14 of that biochemistry textbook, and it's carefully tucked away to say, we're only going to be discussing left-handed amino acids from here on. I found that out between the first and second days of class when I was reading through it. It took me no time at all to figure out that that's a problem for an evolutionist when, as I mentioned, they form in equal quantities. How can you get them to form other than 50-50? Well, you might be able to have some soil clays that will cause it to glom on. Most anybody's ever seen is about 1% in any given direction. You might even have something that is more radical than that, namely the Murchison meteorite that hit Australia on September 27, 1969, which showed a greater proliferation of one over the other. However, it was still, even under those conditions, whatever they were, very far away from 100-0. And that's the key I'm trying to make here. In fact, I'd like to point out a sentence in my sophomore organic chemistry textbook mentioning this point. On page 236 of my Morrison and Boyd textbook is the following sentence. Listen to it very carefully. Each one of these compounds, it can be called by other names, by the way. Stereoisomers, enantiomers, mirror image compounds. These authors call them optically active compounds. The only way you can tell the difference, by the way, is to put them under plane polarized light. One will turn it in one direction by so many degrees, and the other by the same number of degrees in the opposite directions. Sometimes also you can form compounds with other things to make the identification, but they have to be, but you have to control the circumstances too. You might be able to get the amounts to turn to be bigger so that you can see them better. But listen to this. It says, indeed, we deal with optically active substances to an extent that we may not realize. We eat optically active bread and optically active meat, live in houses, wear clothes, and read books made of optically active cellulose. The proteins that make up our muscles and other tissues, the glycogen in our liver and in our blood, the enzymes and hormones that enable us to grow and that regulate our bodily processes, all these are optically active. Naturally occurring compounds are optically active because the enzymes that bring about their formation, and often the raw materials from which they are made, are themselves optically active. As to the origin of the optically active enzymes, we can only speculate. The situation is no better now than it was when this book was being printed in 1972. In fact, the problem was known for more than 100 years before that. We have not made any progress since then in that direction for those who want to continue to explore things. We'll still
roll
be
up their
happy
sleeves.
to.
Let's find out.
We'll still be happy to, but I'd like to point out that's not a good track record for more than a century. Yes, a question at this point.
There's a question. So 50% of the time, if it happens outside of animals and stuff, or plants and animals, right, organisms, it happens 50% of the time, is what you're saying? And then,
No.
I'm not understanding that.
If we give it raw ingredients like nitrogen compounds, oxygen compounds, carbon, functional groups, what we will get in the laboratory is a 50-50 mixture. 50% will be left-handed, 50% right-handed. Do you recall, for example,
So then in 100% of the time it happens in organisms, it happens left-handed,
In organisms, the only amino acids that appear in proteins as opposed to other structures, like bacterial cell walls where they're right-handed, is left-handed.
So then they could have passed that gene on to produce them that way.
My problem is how do you get it started in the first place?
Well, the first one probably started out left-handed, and they reproduced after that same thing.
Let me see if I can point out something, if you don't mind. Isaac Asimov, in a paper that I don't have anymore, I read the article, though, since somebody produced it for me many years ago, went through all the different speculations that were around at the time, and all he could say was, it just happened one way or the other. My question to Mr. Dr. Asimov would have been, how do you know that it did so across the entire face of the globe before there were any living organisms especially?
Well, you just said it happened 50-50, so 50% of the time it could happen one way, 50% of the time it could happen another way. One of those ways it happened, this flip of the coin, it happens left-handed. Those things keep reproducing left-handed or left.
Well, but you see, there's where the speculation comes in, if I may say so, and that is, why wouldn't right-handed ones also form chains? Because they have an equal degree of probability of forming chains than all left-handed ones do. Mixtures, by the way, don't form too well.
If left beat it to the punch, I mean, not that there's a competition, but if left was the first one to happen and that reproduced more than the right did, maybe, I don't know.
But of course, that is a hypothesis, and a hypothesis that's never been demonstrated by observation.
Well, yeah, we've never seen, life form. We haven't produced it right in front of us.
We don't even know. We have never seen anything other than equal mixtures of 50-50 in the laboratory under controlled conditions.
Correct. Yeah, outside of organisms. But if organisms that reproduce and pass on these same genes produce these things the exact same way, left-handed, that seems to make sense to me instead of being completely random.
Well, certainly that's the situation now.
I might be wrong, but...
Well, certainly that's the situation now, but of course you have that awful step of what turned non-life into life to cross.
Yeah, I agree, and I don't know.
That's right, that's right. Okay, thank you for your spirited discussion.
And
yes.
I got a question off camera. What if we go to another planet and, oh, lo and behold, there's 9.5% right-handed ones?
We have the same problem and explanation because it's not 50-50.
It's not 50-50 because that was done in a laboratory, which is not exactly an environmentally true, valid experiment for...
What I'm trying to say about the environment, the laboratory environment, is that it is controlled. It is where you can perform measurements and tests under that circumstance, under that controlled environment, whereby we might be able to see if there is any preference due to some factor or factors, and if so, what the factors would be. So far, nothing has emerged. But since we are empiricists, we continue to look to see if there are any.
I like that.
Glycine, for example,
Last part.
because it has hydrogen as the other component, cannot be distinguished left from right-handed. And so people have tried to do experiments on glycine to see what would prefer one of the hydrogens to the other in the hopes of finding that answer. That also has not revealed anything yet, though. Yes, another question, please. A comment.
Well, your assessment that in the environment it's 50-50, in life it's 100% one and 0 the other.
For proteins, yes.
Right, for proteins. And you're saying that's a problem for evolution. You finally are hitting what actually is evolution. Your initial definition has nothing to do with biological evolution. You're finally hitting now biological evolution. Evolution, the theory of evolution, comes from a single life forms and everything diversifies from that. That actually is exactly what evolution would predict. You are actually now finally supporting evolution. It would say a single cell, a single life form starts, and then everything diversifies from that. Its own trait of being, and admitted, we don't know why it would form left instead of right. Asimov was right. It did, the first life form did apparently form left-handed. But given that as a starting point, and evolution does not say how life started, but given that as a starting point, then yes, everything would follow that it would continue throughout 100% throughout life if everything has a common ancestor to be left-handed.
Well, that of course presumes the starting point, and I would argue that there's a great gap getting there. In fact, if anything, this is evolution of the gaps, yes?
Abelgenesis has not been proven, I'll grant you that.
We
don't have that as an answer, but you're finally now talking evolution, And evolution says exactly that that would be the case, 100% one, 0 the other.
Well, yeah, we can.
But how to get to that point, I can't tell you the answer, that's true.
Right, well, we can also discuss the definitions, and I said from my starting point, you could call whatever my starting point is by whatever name you like. If you don't like the name evolution, then just call it by your own convenient
I
name.
didn't worry about that until you hit biological evolution,
right.
and I agree with you on...
Yeah, and this is somewhat abiotic too, I might point out, since we don't have a life yet. I'm just trying to point out that the laboratory conditions
will give you 50-50.
50-50 mixture every time.
Right.
Yeah, and that's nice data that we can rely upon. And these are some of the books that I also used. The two on the left, of course, are the textbooks, and the two on the right are popular books. The one in the lower right is Flaws in the Theory of Evolution, which is I would say it's a classic book. In fact, my two binders there are my surviving copy of it. It was written in 1961 by a prodigy of a doctor known as Evan Shute, who was investigating vitamin E in the 1930s. Nowadays, it's not so much favored that we go with vitamin E, but that shows how the experiments go way back. The foreword describing his vita is rather revealing. In fact, I watched somebody's eyes open considerably when watching the acumen of this individual. Do we have any more questions on that subject, by the way?
I think we're way
Sure.
past the 10 minutes
Okay.
on.
All right,
Are you
fine.
ready for the next one?
Oh, yes, I'm in.
Okay,
Okay.
10 minutes, please.
Now, these next are not my particular strength or concentrations, but I'm going to mention them anyway because Bruce wanted me to cover those among the 16 that I mentioned. The first one of these is, how does metamorphosis occur? I'd like to distinguish between insect metamorphosis and amphibian metamorphosis. I'm just going to be covering the matter of one aspect of insect metamorphosis. This is another way of describing it. We have a cycle of life, if you like, that goes from egg to larva to pupa to adult. Now, any one of these transitions might be argued, how could it occur by chance? But let's suppose that I just give you 3 of the 4. I get to pick which 3, obviously. Suppose I say that I'll give you that the adult lays eggs, and that the eggs hatch into larvae. Thank you very much for your time, for anybody who's leaving, by the way. And that the larvae go into a pupa stage. Would somebody please tell me how that pupa, in its mushy state, not in control of its own destiny, turns into an adult? Certainly for further investigation. I see somebody who already has an answer.
Well, I've always understood that it is dormant stem cells which become active in that soup within the cocoon.
Mm-hmm. Largely, however, I could pull up some quotes that I have saved further down to show that all camps at this point, even modern day, from the creationists, the old Earth creationists, and the evolutionists, all concede that it's a mystery. All right.
It's a mystery now.
Fine, we can be as empirical as we want and say now.
Let's say that we can't see it. We can't have that answer that you asked. Among all the other answers you previously asked, in the next 100 years, 0 improvement, or finding out the mysteries of all the things that you've asked, all the 10 or 11 points so far with all the subcategories that you have. What about 500 years? Are we going to find out how a pupa works in 500 years? Maybe. I hope so. What about 1,000 years? 10,000? 100,000 years? We're going to figure this stuff out, don't you think?
Well, actually,
don't you think we're going to figure it out?
Actually, I might point out to you that even from a philosophical basis from which you're following now, we have no assurance of finding or not finding anything. We may or may not, depending upon what the evidence shows. We shall be happy to continue to investigate for all the evidence and all the methods and so forth that we wish. But even philosophically, we have no actual guarantees. We only have that we have no guarantee if we don't pursue it at all. That's all we do know.
So you're saying we should pursue it then?
Of course we should.
Okay.
Of course we should.
You think that of all the unknowns of science in the last 200 years that have spurred on the quest for knowledge for science, and we've answered many unknown questions. How did a rainbow appear? 500 years ago, we didn't know. We do know now. In fact, elementary school children know now. Do you think that it's a probability a great probability that we will know many of the answers that you are questioning tonight.
I don't think it's wise, at least for me, to speculate what we will or we won't know. All I can say is that if we are being true empiricists, we should continue to search as far as we can here, and to the extent that we can, we should leave it. We should say that more searching would be required, but that we don't have yet an answer.
I got a great conclusion for this. I think that if we take your head after you die and save it in one of those icebergs, and then come back in 100,000 years, and you can give the same speech and say, look at all the things that I said 100,000 years ago that are now children's play.
All right, well, in the meantime, even if we were to do so, I would not be dispirited to find out that somebody said that saw that I said those things, because after all, that was the state of affairs then. I would have been not true to...
As it was hundreds of years ago.
Oh, fine, okay, fine. Then again. But we also have to allow for the possibility that maybe they're not going to be solvable either.
I'm looking forward to that, because it only asks more questions that we can answer.
Fine. Well, we can shake hands and have a bite to eat, too.
What if you waste the 10 minutes?
Yes, yes.
Oh, we have a question.
Just waste time, Bruce.
I'm sorry.
And Dave?
Because you brought it up, we're talking about reductionism here. The idea that scientific discovery usually involves some kinds of reducing things down to its component parts. The light microscope revealed the relationship between chromosomes and cellular division. The electron microscope allowed visualization of genes and even DNA molecules within the chromosomes. Chemical analysis and X-ray diffraction studies have revealed the specific structure of DNA, base pairing the roles of DNA, RNA, rRNA, mRNA, tRNA, and various enzymes in the genetics heredity. But, however, reductionism is only useful for explaining the operation of the machine, not its origin. So the more complex that the more study we do, the more it points to an infinitely intelligent creator, not how it happened naturally. So the more we study, the more it points to God.
Or another thing we could say sometimes is that if we have to perform an inordinate number of experiments to find out something or to create something, that might be testimony. Might be testimony all the more in the direction of that a non-neutral source of motivation was required to get there in the first place. It might be.
I'm sorry, I have to get this next part on camera. Carl Sagan said that a good science question answers one question but brings up two more.
All right, taken. Hopefully I can get this to produce. This is Dave's additional comments.
We might want to look at metamorphosis. Most insects, about 87%, undergo a complete metamorphosis. That is, a larva, such as a caterpillar, builds a cocoon or chrysalis around itself. Its body inside then disintegrates into a thick pulp-like liquid. Days, weeks, or months later, the adult insect emerges, one that is dramatically different, amazingly capable, and often beautiful, such as a butterfly. The food, habitat, and behavior of the larva are so different from those of the adult, it's hard to imagine. What mutations could improve a larva? Certainly none that destroyed its nerves, muscles, eyes, brain, and most other organs, as occurs within the cocoon. So even if the larva improved, it later ends up as mush. From the evolutionary standpoint, liquefying complex organs is a giant step in the wrong direction. Millions of changes inside the thick liquid never produce something survivable or advantageous in the outside world until the adult completely forms. How did the genetic material for both larva and adult develop? Which came first, the larva or the adult? What mutations could transform a crawling larva into a flying monarch butterfly that can accurately navigate 3,000 miles using a brain the size of a head of a pin? Indeed, why should a larva evolve in the first place? Because it can't reproduce.
Take a bow for that one. The next topic I'd like to take up now is how do major morphological changes occur? I find this to be an interesting phrase because morphology means changes in a way. It's kind of like the Rio Grande River or the personal identification number. Here's a little bit of a busy chart. these are some of the major morphological changes that would have to occur. Between, first of all, a fish and an amphibian, we'd have to go from no metamorphosis to metamorphosis, and we'd have to go from a 2-chambered heart to a 3-chambered heart. If we go from an amphibian to a reptile, we have to lose the metamorphosis that we gained, and the fertilization would have to go from external to internal. If we go from the reptile to the bird, then we have to go from cold-blooded to warm-blooded, which is also, if you went in the direction of mammal, and scales to feathers. If to the mammal, scales to hair. If, on the other hand, you wanted to pursue the alternative of birds to mammals, then you'd have to go from wings to hands, paws and hooves, and feathers to hair. None of these, at present, has any reasonable hope of being fulfilled. In fact, there are a lot of things that would have to occur for any one of those, and undoubtedly there are many other morphological changes that would have to be true between them. Now, you might argue, for example, that it depends upon which fish you might have, and you might have an evolution of fishes, and so forth. The point is, you still have to have a transition at some point from fish to amphibian for the scheme to be fulfilled. And it's at that point of transition that I'm speaking, because all fish have the same problems, or all such transitions, no matter how close they might be together, would have the same problems. Not just the animals that might seem far apart from each other, as long as they're in those classes. Here are some additional comments, once this comes up, on the matter of feathers.
Well, never mind, evolutionists still insist that feathers evolved from reptile scales, specifically dinosaur scales, and to prove the point, they say that feathers and scales are so similar you can hardly tell them apart. Have you noticed that? One of the first people to say this was Gerhard Heilmann back in 1927. In his book, The Origin of Birds, he says the most striking peculiarity of birds is their plumage, which apparently has nothing at all in common with the scaly covering of reptiles. So much more surprising is it, on examining these structures in the microscope, to learn that the feather is nothing but a further development of the scale. Alfred Romer, very distinguished evolutionist, says birds have been called glorified reptiles. Feathers are in reality almost their only distinctive feature. And he says, although these structures seem quite different from the horny scales that cover a reptile's body, the difference is in reality not very great. Well, you can look in your Encarta encyclopedia, if you have one on your computer, look up feathers, and they will confidently declare that the feather is a horny outgrowth of skin peculiar to the bird, but similar in structure and origin to the scales of fish and reptiles. So I thought we'd do a little test. I had a laboratory technician that worked for me. They had a pet boa constrictor. And I said, hey, the next time that little rascal sheds its skin, why don't you bring it on in and we'll look at it in the microscope, because I understand you can hardly tell a reptile scale from a feather. And so she did. She waited, and when this little rascal shed his skin, and by the way, I want to point out that no snakes were destroyed to do this study. We waited until they shed naturally. She brought the skin in, we put it under the microscope, and we magnified it. And this is what a boa constrictor scale looks like here. You can see the others around it. And as the evolutionists have told us, if you look at them in the microscope at least, they are remarkably similar to a feather. So then I took a picture of a feather, and I want you to see if you can tell the difference. So you may want to clean your glasses or something right now. If you got this one in mind, okay, if you get confused, just look at the top. It'll tell you which is which. Okay, that's the scale. This is a feather. What do you think? Should I go back and forth? You got it down? Or I mean, why do they say they're similar when they're absolutely not similar? In fact, I'll go further than that. They are totally different. Their mature structure is dissimilar, their function is dissimilar, their embryological development is dissimilar, their mechanism of growth is dissimilar, their mechanism of replacement is dissimilar, their chemical composition is dissimilar. And let's just look at the obvious. Scales are like folds in drapery, like drapery pleats. It's all one sheet. That's like when a reptile sheds scales. He doesn't shed them one at a time or two at a time, does he? The whole thing comes off as one sheet. In fact, reptiles typically have two layers, won't they? An outer layer and an under layer. When they shed the outer layer, then the under layer is exposed. Why do they do that, by the way? Why do they shed their skin? because they're growing. Now, I want you to think about this. You get a box through the mail, and you're wondering what's in the box. You open up the box, you know what's in the box? A bigger box. So you shed the outer layer because the under layer is bigger. You got to think about that a while. Let's look at that boa constrictor skin. The tail's in the direction of the arrow. So to your upper right, that would be the tail. I don't know, 1/4 of a mile up there or something like that at this magnification. And you can see the scales are arranged in rows, sort of on the bias with the long axis of the snake. If we get a hold of the right side and flip it over like the page in a book, this is what the underside of the skin looks like. And so now the tail's in the direction to the upper left corner. And again, for those of you in the cheaper seats, let's magnify this a bit. This is where one scale just fit right underneath here. It fit right in there, so when the skin pulled off, that scale pulled right out of that pocket, like taking your hand out of a glove. And that's the way the scales are put together, is one continuous sheet. Now, feathers are completely different. Feathers grow out of follicles, just like hair. Hair grows out of a hair follicle. Feathers grow out of a feather follicle. But I'm here to tell you there's no such thing as a scale follicle. Now, what is a follicle as it relates to feathers and hair? It's a tube-like depression in the skin. You see it here. Goes down deep in the skin. All of the growth occurs in the bottom in what's called a growth collar. The feather grows out sort of looking like a thick hair. And when it comes out of to the surface of the skin, it all unfolds to make the feather. This is the way the feather follicle looks down in the skin. All of the growth is occurring here, and the feather's alive at this point, but as it makes all of its parts, it dies. It goes through a programmed cell death so that the feather that emerges from the skin is completely dead. This is how it all develops. Inside the shell here, we have what we call a pin feather. If you peel this shell away, you can see that this is the growth region at the bottom. The shaft goes up along the backside there, and then the barbs grow off this growth ring, and those little barbs get longer and longer. They grow from each side and meet at the other side. When the feather comes out of the follicle, this cylinder opens up, the barbs all swing down, and you get this big broad feather out of a hole in the skin that's not much bigger than a shaft. And that's the way each feather grows from living cells, goes through a programmed cell death, and rises up out of the follicle in that way.
That's the end of the film clip. Do we have any questions on that section?
I think we're going to have to skip it and we're going to save any time. We only have about 25 minutes left max. Do you have a closing statement?
We have one last category.
Okay.
And that is...
How many other categories?
That is at the end of it.
We started at 7:20, so...
I know.
All right. What creates information gibberish is our final topic tonight.
Okay.
And I'd like to point out something about information. If we were to have, say, a series of numbers in a row, well, how do we determine whether or not that series of numbers is like throwing letters in a box and shaking them up or not? We have actual measures. One of them is called the autocorrelation function. Now, I'm not going to go into detail at all about what these are because that would require a long explanation, which is you were wanting to stray away from things being above the ken of the audience. But the glorified version is called the ambiguity function. And if you were to, sorry, one moment. You can find out more about these in, as I pictured, Merrill Skolnick in picture. That's the common version, the third edition of Radar Handbook. It's a standard text that is used in virtually every aerospace company in the world. If you want to vary a code, you look into things like this, very much so. Information is required to get any of the structures that we have. Information, by the way, requires a sender tuned to the receiver tuned to the sender, and a medium which promotes rather than interferes with the communication. There also has to be a language whereby the sender and the receiver can understand each other and that they perform a task in connection with it as proof that in fact communication is occurring. Every one of those items is right now a big unknown as to its origin. And that's the key. How would you get from infinitesimals to that point? Surely we shall continue to look forward to such things. In the meantime, we have a function that begins to look a lot like the entropy function to measure the disorder in communication when things are shaken up. In fact, they are perfectly parallel to each other, any more than mechanical devices are parallel to electrical devices in the book, in a physics book. They have the same forms all the way down the line. That's what we have in the case of the entropy function for both of them. Let me come back. And without that information, we don't have any enzymes coding for DNA, and we don't have any DNA coding for the enzymes. In fact, I would also ask, how are you going to get one to code for the other and the other for the one when you only have it maybe at one at most in the first place, let alone the medium? These are some of the mysteries that we have left to discover after a long time trying to discover them. But it all centers around the question of information. And I might point out, by the way, that in a certain sense that brings me to a circle. You remember how I started off this talk with, among other things, Roget's Pocket Thesaurus? This is a book of information. So we've made effectively a grand circle now. Information began this talk and ended it as well. Do we have any questions on that point, by any chance? Any?
Are you defining information as DNA?
I would say that information is coded in it. It's not information itself.
Well, we only have 4 proteins for DNA.
Mm-hmm.
How is information encoded in that besides the nucleotides that are binding them together?
Are you asking a question that doesn't have an answer yet, or what?
Well, you're saying that the information is encoded in the DNA.
Mm-hmm.
If we take 1 AG, is there information there? Or is it a string of information that you're talking, a string of DNA that you're talking about that considers information to make proteins?
Okay, you said AG, are you referring to 2 of the 4
That's
letters?
Correct. Just take 2. Is there
Yes.
information there? And if it is,
probably not enough by itself, but it certainly would be required in the
so
entire
you're saying that a number of different molecules of DNA produces information that produces proteins that makes enzymes and
well,
everything else?
each one of them would have its own, which would have its own.
I'm just trying to
coding, yes.
define information now. So now that we're getting close to it, how would you define information? Can you tell me how would you define it?
Well, information would, I believe, be defined only by the context in which it operates. For example, if you had just a series of letters in any particular order, it might not convey any particular meaning, except if it's in a context that understands that meaning. If we, for example, use the word scale, S-C-A-L-E, it might actually have several different meanings too. Or it might have a word that has really only one, but it's only in the context. Also, if I put the word scale into a foreign language to English, it might not have any meaning at all. It depends upon the context in the use to which it's being put.
Is meaning equal information? If it doesn't have any meaning, that means there's no information there, or is it just hidden information that we don't understand?
We could speculate all we want.
No, I'm asking your opinion.
Oh, okay.
I'm not asking for speculation. I'm asking you, if you see the word scale spelled backwards, and it doesn't mean anything to you, does that mean there's no information there, or there is information there?
Well, somebody else might be able to interpret it better, too.
So does that mean that could be information, or it could not be information, if nobody can interpret it for anything?
Well, it may or may not be, depending upon, and by a context, and I would argue also the context has to be already there to have that information be conveying anything at all.
So you're admitting that some information, some DNA, I'm talking about particular DNA versus letters, some of it could be non-information, and some of it that we well know now is information, but some of it might not be information. Is what you're talking about?
I was referring to just information in general. If you want to tie it to a particular thing, if you're tying it to a particular...
I think we're talking about evolution, let's talk DNA.
Well, okay. So, for example, might you be mildly referring to vestigial organs and the like, or just junk DNA or this sort of thing, as it's called?
It was thought once that junk DNA was not information. Now we know that it does play a big part. So we're not speculating here. We know now that some junk DNA actually does do the turning on and turning off of certain genes.
That's right, we do. In fact, we continue to explore further to find out whether or not, in fact, it really was junk DNA, any more than whether vestigial organs were really vestigial, and I believe all of them have been put to rest.
Let's take a bacteria that only has maybe 200 chromosomes, 200 pairs. A bacteria that only has 200 pairs of nucleotides. Is that information?
Well, does it perform a function? Because
yes, it does.
All right, so therefore it is enough to perform that function.
And suppose that there are certain parts of those nucleotides that, as far as we know, don't serve a function and don't communicate with anything else. They don't convey anything, like you mentioned before, in the context of conveying information to do that. Or would we call that non-information?
Well, we might not yet be credited with doing so, because among other things, it might require our further discovery as to whether or not there really is a function after all that we just have not discovered.
Okay, well, let's go ahead and take a probability then, because we're talking probabilities. Science does probabilities most of the time. Science is never 100%. Let's say that there's a certain percentage of our DNA in everybody's body that is not information, meaning that it conveys absolutely nothing. And probably in the years ahead of us, probably will not convey information even as we go further and dissect the DNA to find out what is information. Would you admit that there's some DNA in our bodies that do not convey any information and probably will not convey any, probably will not find out that it conveys any information in the future?
I want to reserve judgment on that. It would require the actual circumstance. And
I'm just talking probability.
I don't have any.
Don't you think it's probable that some DNA is real junk with no information at all?
It's much harder to discover. For among other things, there are such things as redundancies, and there are also empty areas that can be filled later with information that doesn't happen to have any in the currency. So it's not evident, particularly from just that much, and it might not be for some time. It depends on the circumstances, I would say.
So you're saying that there is a very, very little probability that there's any information within the DNA structure that we have that is not information?
Well, it's pure speculation on my point, and a philosophical point at that. I would say the best that I could do at this point is to say it's my belief, and that's all I can say, that everything would have an eventual purpose that has yet to be discovered. That is all that I could assign to it, however, is a belief. That's all we can, unless we have something to show us one way or the other, being as that I'm an empiricist.
Well taken.
You're welcome. Anything else? Yes?
I mean, I don't know how many times you hammered the point observation. You know, this is all about observation, and it just kept on coming to you. As far as evolution, it's the theory of evolution, but it's always taught as fact. As a matter of fact, my niece that just went through a Christian in Riverside, prominent Christian elementary school, junior high school, and high school, was taught evolution. She was taught it was a fact in a Christian school that was regulated by the government to teach evolution and not creation. And so I think Bruce said to begin with, the 47% of Christians believe in evolution. I would say that they're not really Christians at all, including the Catholics. All you have to do is go back to the Reformation and Martin Luther, see that Catholics aren't Christians. And so what we're left with as Christians is we go back to Scripture. It's not observation, but when we go back to Scripture in Genesis, and then we go to Genesis 11, the genealogy, we can see that Christianity didn't start in the year 1300. It started with Adam at the beginning of time, when everything was created, including the universe. And Scripture tells that to us in the original Hebrew language. When he says that, you know, on the first day this was created, on the second day that was created, those are in the Hebrew text. Those are actually 24-hour periods. So
I have to ask: is there a question?
No, but I've been saving this up. All your other guys, they had about 10 different chances to come up to the microphone.
Oh, yes, but they had questions. Do you have a question?
So no, they didn't really have questions. Well, they had a lot of opinions and theories when it was supposed to be observation. But anyway, my niece went to university. She's not a Christian anymore, but she says she's a Christian. Everybody says they're a Christian. 47% of most Americans say they're Christian. They're not really Christian according to the Bible. The Bible says a Christian has a regenerated soul, which God saved. Okay? So anybody can say they're Christian. So I'm going to get to a question.
Focus, please.
Okay,
Yes.
I'm going to get to a question. Now, as far as observation goes, the evolutionist says that including some people that say they're Christians, that the universe or the Earth is 13 to 15 billion years old. Who was here for a million years or billion years or 13 or 15 billion years to observe that it's that long, that old? And is there, my understanding is there's a lot of inconsistencies in errors in carbon dating, radiocarbon dating. So my question would be, how could they observe billions, if not millions of years, number one? Number two, is they try to use radiocarbon dating, and is that erroneous as far as your, yeah, that's my question.
Okay. I will leave it at that then. Well, that's a mouthful, I should say. I suppose I'll offer a few thoughts of mine, or a few more remarks. One is, I would hold the position that whatever we didn't see doesn't constitute science. It constitutes extrapolation at best. And we have a hard enough time trying to do interpolation, that is filling in points in between known ones, let alone trying to extend points beyond their boundaries to extrapolation. And in Wikipedia, we can find a definition of extrapolation that more or less says that it's not to be as relied upon as interpolation, if at all. So that's just a comment upon extrapolation. In other words, extrapolation is a lot more prone to mischief than interpolation is. And there are no universal interpolation methods even for things that have the same degree of correlation coefficient, let alone extrapolation. I had more to say, but do you have another question right now?
No, keep going.
Okay. As for dating methods, people would make the rough equivalence between that and firing a gun, and that is that we could back calculate where the bullet came from. I would say, however, we have a number of tests that we have been able to apply and sift out any noise to come to such conclusions where we might not have that same degree of data available to us. In particular, in the case of bullet firing, we can actually repeat the tests over and over and over again before we decide upon our great unknown bullet, what became of it, whereas we don't quite have that available in the case of dating methods. As for carbon dating, there have been some observations which have been in dispute or not, depending upon the camps from which they came. Recalling carbon-14 is produced from nitrogen-14, not carbon-12, so that essentially we have carbon in one track, and that's carbon-12, and carbon-14 in another. They mix together. When the organism dies is when the carbon begins to deteriorate to not carbon-12, but nitrogen-14. Now it's a question of the methods and whether or not you have to apply corrections and calibration curves and the like. One thing that is generally not yet addressed completely to everybody's satisfaction of whatever camp there is, with all due respect, is whether or not things that would portend perhaps a younger age than another is due to contamination on the basis of samples, on the general belief there's always going to be contamination and so forth. This is a highly debated topic between old Earth and young Earth creationists besides the evolutionists. Those are some initial comments that I would have upon it. However, if you have something that has if I'm not mistaken, every single sample that has that has any carbon in it at all has carbon-14 in it too. And since measurable levels of carbon-14 are only found in samples at least 100,000 years or less old, that would mean that we would hypothesize, in fact, greatly that the sample itself would also not be greater than 100,000 years. Initial comments, yes. They could be modified, of course.
Okay, and yeah, I mean, obviously the Bible says that God created everything ex nihilo, out of nothing, as the Big Bang says, basically everything's created out of nothing, and which takes a lot more faith than I think.
No, the Big Bang says it's created from a singularity. Singularity is not absolutely nothing.
Okay. Well, okay.
There's a big difference.
So it may be a possibility that God could create an old Earth instead of taking billions of years and trillions of light years for the stars to expand. That God could set them all in place where they're at right now, and because nobody's been around long enough to observe it really expanding that I know of. And just my last comment is, I think it was Ken Gentry did a study on polonium in the granite, where the radioactive halos had solidified and cooled instantaneously, where evolution says it takes millions of years. Can you offer your opinion on that?
Well, it's been argued on that side, and I can only say at this point, even that's disputed by the people who hold that camp. As far as general sorts of comments, I might even defer to Don at this point, because Don wrote a whole book on the subject, didn't you? He did indeed. About, well, from an older creation standpoint.
What happens in the polonium sequence is there's a gas that actually leads through microfissures. So it isn't, you don't have to have the parent product present.
By the way, that reminds me also, in the case of dating methods, those that have to pass through a gas are suspect in some sense. That's my opinion. For example, if you go from any of the 3 uraniums to the lead, you pass through radon to get there.
Radon is the gas that is polonium.
Well, polonium is actually below radon in its molecular weight and atomic number. It's at 84, whereas radon is 86. And generally, you go downhill as you radioactive decay. Sometimes not, but most of the time, yes.
Between uranium and polonium.
There are a lot of steps. 12 or total 14.
In the isotopic numbers, there's a couple of jags.
There are, yes.
And indeed, the radon is a step in the direction of polonium. It's I think, immediately before.
That's a little.
Yeah. Okay. That's a technical term. Yes. But in any event, I refer you to Don for that particular perspective.
Let's have a beer over that one, Don, I tell you.
All right.
You can talk, I'll listen. Just for the record, are you a young Earth or old Earth creationist?
I happen to hold the young Earth creationist view, and I'd also like to mention something in its favor that I have not gotten to mention at this point, and that would be Niagara Falls. Niagara Falls, in its current erosion rate, is said to, that is, if it were to continue to hold, and if after all the present is the key to the past, we would say that's the case, could not be older than, say, about 9,000 years at most. And that would be one evidence I would point in that favor. There might be others.
When you cite some of these studies that you've cited, do you take into consideration the percentage of scientists in a very narrow, a sliver of field of study? Do you count their consensus at all? For instance, the young Earth creationists are generally thinking that only 1 or 2% of life Earth scientists agree with them. 99% of the thousands of scientists in all the different life Earth studies disagree with the young Earth creationist view. Now, if I was a doctor, if I was a patient at a hospital, and I asked a doctor, does this medicine work? And he says, well, 99% of the time it works. And he goes, well, I want a second opinion, I say. So another doctor comes in and says, this works 1% of the time. Which one do you think that I would choose? And I'm asking you, as an intellectual, why would you choose? That's a compliment.
Yes, thank you.
I think everybody here knows that you're fairer than the smartest bear, or smarter than the fairest bear. That's not how it goes.
Smarter than the average bear.
My wife says that too.
Yogi Bear, yes.
My wife, I hope she's not listening.
Yes,
smarter than the average bear. Thank you.
Yes,
Why are you consistently agreeing with the 1% and this other 99% of the consensus out there from all these other life sciences disagree with your view? I would think that if I was a layperson, as I am in many of the fields that you are an expert at, I don't have the time to research all of these things. But what I do is I say, I look at the scientists that build planes. I look at scientists that detect climate change. I look at the scientists that build my brakes in my car. And I look at the consensus of those scientists. And if those scientists seem to have a very, very high consensus, sometimes over 99%, as with airplanes, that
I have my faith or trust in riding in an airplane. Why do you think that young Earth creationists only choose the fields of study that they disagree with religiously? They'll fly a plane, they'll take the medicine, they'll take the cars, but in all the fields of study that they conflict with their religion, they're against it. But all the other thousands of different fields of study, they agree with the scientists. Why do you think that is?
It's quite an editorial comment, isn't it?
Well, it ends up with a question.
Well, of course it does, and it should.
You're welcome to have another question.
Christian scientists.
Yeah, scientists who are Christians. Well,
did I say Christian scientists?
No, I say Christian scientists.
Yes, we understand that Christian scientists are probably neither.
Why
Yes.
do you think they agree with one side of consensus and not the other, depending because of their religious views?
Okay, well, first of all, I would say that I'm an empiricist first, as far as science is concerned. I'm going to go where the evidence leads, regardless of what others say.
But the consensus is what I'm talking about.
But you see, what should govern science, in my estimation, is where the evidence leads.
So you're saying your evidence points to the 1%, is what you're saying?
Wherever it leads. I don't care.
Well, it's obvious that you believe in that 1%.
But I do because I believe the evidence points that way, not because I hold...
And why do you think that the other 99% of the scientists think that the evidence points the opposite way?
I don't think it's 99%.
You'll have to ask them to see whether or not they are as empirical as they claim to be. That's all I have to say for them.
Do you think that they argue, that they don't argue, they say, oh yeah, that sounds good? It took 30 years for tectonic plate theory to become a consensus, a good consensus. Sometimes longer for other fields of study. Paleontologists argue for decades over bones. I can't see arguing over decades, but they do finally come to a consensus over a period of time.
Well, I'm sure.
And you're against those consensus.
No.
Even though they have argued and debated and come up with some type of consensus, they never are 100%, and I agree with that science is never 100%. And you had a slide up there from 1927.
That was on purpose. I was trying to show the antiquity
Give me a
of it.
break.
Oh, but you see,
That's almost 90 years.
That wasn't the only slide in that connection either.
I saw the 97 in there as well. That's right.
That's
27,
right.
I'm ashamed.
No, that's what it's saying is that the consensus is still held since then up till now. Now, in any event, to try to answer your editorial comment before it goes all over the place and we consume all of our time that's remaining, I would like to address it by saying, once again, I would go, if my better angels are on my shoulders, and I hope they always are, where the evidence leads. And remember also this much, that just because something is in the minority does not mean that it does not have truth in it. After all, every single scientific theory, if I'm not mistaken, started off as a minority, and a vast minority opinion at that, and even those that were returned to, it's my belief, would also largely be in the minority. If something is in the majority, there probably is good reason why somebody thought that way. But being an empiricist, I would still want to make sure that I had access to being able to check even that which seems to be well established. For it might be that somebody missed something in the process that must be always admitted as a possibility, because as we said, we don't know a millionth of 1% about
I think
anything.
that there's an exception to that. And let me mention it, and then you can comment on it. Evolution has so much evidence building upon it. Every year, there's more and more and more evidence. That theory will never fail, because there are so many fields of study, hundreds of fields of study that support the idea that evolution is true.
Is it a theory?
When you're if you can talk at your own time, sir.
You're going on and on.
I'm almost done. You can talk on your own time. One person talking, that's the rule here, and I'm almost done. Why do you think that there's so much...
Yes, please let him talk.
Why do you think that there is so much building, so much growth of evidence that evolution, that you reject not only the consensus of 99%, but this vast amount of evidence that you can see with your own hands and your own eyes?
Because among other things, I see things that go clear in the other direction that don't seem to have any answers at all. Everything from the point of the beginning all the way up until now. That's why. That's being true to being an empiricist. And by the way, just if something does have a large body of those or people or evidences that seem to point in one direction, that does give it merit to be discussed. If only a small amount ever, a space in the fringe end, ever came up with something, that may be a clue to that it isn't worth discussing. Maybe, but not necessarily. Okay, yes?
Just like you said, just because there's a preponderance of people that believe a certain thing does not necessarily make it true. As a matter of fact, there's books out there, Slaughter of the Dissidents by Jared Bergman, who has 4 earned doctorates and 5 master's degrees. And basically what he showed was that in every, and Morris said the same thing, you can't be in about 6 different fields in any major university and hold to a non-evolutionist position. You'll either lose your tenure if you're teaching, or you'll lose your, you won't graduate. So that's the problem, is we've been taken over by a political thing. This was happening back in the days of England when Huxley was in charge of this club, the X Club, which had to pass, all scientific journals had to go through this in order to be published. Now we're seeing this happening today. I go to the International Creation Conference. I spoke at the last International Creation Conference. It only meets every 5 years. Every single one of these, many of them have over 4 earned doctorates. Every single one is a young Earth creationist. So just the problem is, once you look at the evidence, and that's why Bruce keeps going back, I believe, to this, well, there's a preponderance of scientists who believe it, because he can't support it with any evidence to support evolution.
Yes, I believe that's the 50 million Frenchmen can't all be wrong fallacy.
Right.
More than we had this, the true Scotsman fallacy a few months ago.
If you don't have an argument, if you don't have evidence, then you go to that fallacy.
May I comment on that before our next speaker?
Yeah.
Just really quickly.
It's your floor, yes.
Well,
You're sitting on the floor, right? Oh, no, go ahead, go ahead.
I'll relinquish my time for this gentleman.
No, go ahead. We want to hear it. We got time. Everybody has time.
No scientist that I know of ever says they're 100%, but they're waiting for the evidence from the creationists. They're waiting for something to come up. They're waiting for solid evidence. You would get a Nobel Prize, Dave, a Nobel Prize, if you had solid evidence that it was a 6,000-year-old Earth. I mean, that would be terrific. When you say that the people can't study or get a degree, that's beside the point. They can go ahead and find their own evidence outside of that area. And we are willing, we as scientists, I'm not a scientist, I'm talking for the science community, never say we're 100%. We are waiting for that Nobel Prize to happen. We are waiting for that human bone before the rabbit bone in a layer of silt somewhere.
Well, first of all, I didn't entertain a lot of those notions because, as I noted in my third version of the talk, given the correct conditions of temperature, pressure, and humidity, the organism will still do whatever it pleases. Rather, I did decide to concentrate on the things that were before that point, because we have controlled laboratory conditions which cannot be modified by the subject in question. That's why I went for them. And I also didn't entertain much about the matter of age. All I was trying to do is settle the question, or at least discuss the question, of whether it makes more sense to believe in a creation or an evolution by pointing out by negative example that it doesn't make sense in a good many cases for the evolutionary hypothesis. That is the claim I have made in this talk.
Fair enough.
And that's about all I can make at this point, I think. Is there another question or another comment? Yes, thank you very much. May I extend my thanks, by the way, for nearly everybody in this room participating in one point or another. And anybody who hasn't can still come up to the microphone, yeah.
Thank you, Dave, for your presentation.
You're welcome.
For your knowledge as well. My question is I don't quite see how your presentation was different from the God of the Gaps argument, because it's showing it shows where maybe we don't quite know all the answers yet, because it's obvious we don't know where life came from. There's lots of theories, but I don't see how that would, and you never did make the claim that it points towards a God.
Well, I'm not supposed to do so if my goal was to show the contradictions I believe. I'm leaving it to you and to the others as to whether or not I have ruled out the choices. I said extrapolation is fraught with mischief.
Yes.
And so I don't make extrapolations unless there's no other way and I have to make a decision. And I hope that never comes to be the case, because it's not a good way to go, especially if there's some other avenue available. And even so, when being an empiricist, we have to allow the fact that other evidence, other undiscovered methods previously, hitherto, and just general considerations must also be admitted if and when they come in. That's why we don't have any such thing as exactly 0% or exactly 100% probability when it comes to things. I would like to say one thing, however, when it comes to probability. You can take this as a barb if you like. That's the way it's intended. And that goes like this. If there is anything to be spoken of in the endeavor of science, we should hold to the things that are the more probable rather than the less probable. Right now, what we have, in my estimation, is the impossible becoming the possible the plausible, the plausible, the probable, the certain. This is not science. Show me why the impossible should become possible and so forth before we should begin to talk about it, rather than just leaping into it and saying, well, suppose this and suppose that. Otherwise, I would contend with you and with others who would hold to that we're believing in miracles over science. That's not science either.
What's a greater miracle? Imperfect beings coming into existence, or a perfect, all-complex God coming into existence?
Well, we would hold
what's least probable?
Well, first of all, we would never hold that a God came into existence, but that rather God always did exist, and that's as far as you can take it. I mean, after all, God is spirit, according to the Scriptures, and is thus not subject to the laws of thermodynamics, among other things.
So that would be the God of the literal gaps.
Well, if you want to start introducing something into my remarks, I cannot stop you from doing so, but I can point to the fact that I wasn't doing such things. I was leaving it to you and to the others in the audience and those watching, thank you for watching, to see whether or not I've eliminated all the other choices. And if I have not, very well, we have more choices to discuss than the ones I did. But I believe I did an incredible job, at least as far as taking the choices apart.
And thank you for your expertise as well.
You're welcome. Do we have any more questions or comments?
I think that it's about time, Dave. About time, right? Both Daves? Let's give a hand again to Dave, Dana-Bashian. Thank you, Dave. And I hope all of you come to the next debate. And if you haven't seen some of the other debates, they're all online at backyardskeptics.com.
Can anybody identify these 7 modern scientists? Any of them?
Darwin?
No, there's no Darwin in there. Which one and what row?
I'm guessing that they're all Christian scientists.
Well, they weren't evolutionists, is the one thing I would say. Yes? Can you identify any of those? Any at all?
The Galileo upper left-hand corner?
No, there's no Galileo in the pictures.
Newton? I don't know.
Newton is there. Which one?
Second one.
Second from the left.
Second from the left on the top row is correct. Any others?
Kepler.
Kepler, which one?
I'm not sure.
No, you folks asked me to use pictures. He's the first one on the left. All right, any others? They're all very famous, by the way. There's none obscure at all.
Boyle,
Boyle's not there, no. I know. By the way, the third one, the one in red, was notified recently as supposedly having more influence than Jesus. I don't know that I agree with that, but it's been modern. It was just said a few days ago, I think. Carl Linnaeus is the one in red. The one next to him is Michael Faraday. The one at the second row on the left side is James Clerk Maxwell. In the middle is Louis Pasteur, and in the right is Lord Kelvin. All of these, of course, and I could have put many more pictures, of course, are the founders of modern science, and almost all of them were not evolutionists at all. There were a few who were, but most of them weren't. I thought I might just pique your interest with a few pictures of these scientists. These are some of the references that I used. Only 3 of them are Christian, all the others are standard references. And credits to these individuals for the slides. The end.
Okay, another hand. Another hand. Thank you. What? Another hand. Thank you very much. Bye now. And they're all welcome to have a beer. Or not on me.
Or something.
Or dinner, in my case.
No.